Hi, I'm Joseph Calabro, and this is my coursework for the Advanced Maths in Game AI module. So, this module presented the challenge of developing a procedurally generated environment that made use of learnt techniques used within the industry. So, this involved generating a grid of tiles that would then be used to generate terrain, and then pathfinding algorithms to check accessibility to these tiles before spawning objects on them. Clustering was then used on these objects to group them together to ensure a clean-looking environment. So the first thing I did in this project was create a script for generating the tiles. So each tile is represented by a cell object and would be instantiated through a nested for loop that creates the grid you see here. Next was to generate the terrain. This was done through Perlin Noise. A function was made that would generate a texture, a grayscale texture for the Perlin Noise that you can see here. The texture would be mapped to the scale of the environment, so that means essentially that it would be the same scale. So if this was a 50 by 50 grid, then it would be a 50 by 50 texture in pixels. So each pixel would be mapped to each of the tiles you can see here. Each tile would then be scaled using a cutoff value by the respective pixel value. So if a pixel had a value of 0.5, I would multiply that by 10 and scale that tile by 5 on the y-axis. So the generated numbers for each of these would be between 1 and 10. So that created this clean looking environment. After that, I needed to generate some objects in the environment. The first thing I did for that was to create one of the taught pathfinding algorithms. So there were many algorithms we were taught, and I chose the A-star algorithm. I chose this one because it is an algorithm that is guided by the heuristics when creating a path, making it highly efficient and optimized for this project. So that was very important for this project because it needed to run smoothly so that the terrain was generated very efficiently. So as you can see here, there's a path from the player's start position here and to this tile here. This is an example of what the algorithm can do. So when objects were spawned, or before they were spawned, sorry, a path was generated to the tile I wanted to spawn them on. If it returned true, so a path was available, then an object would be spawned there, and that object would be random from within a range of different types of objects. So we have collectible objects like a key, we have chess pieces, and we also have environmental props such as these pillars here. So it would be randomized. The next step after generating these objects was to cluster them into groups, just to make sure they were evenly spread out amongst the environment. So the k-means algorithm was used for this. So the k-means algorithm essentially randomly creates centroids or points within the terrain and then checks the closest objects to these points. What would happen is these objects would be grouped to that point, and then that point would update its position to the average location of those objects. This would keep repeating until the centroids would no longer move, and then it would have a final set of objects that would be paired to that centroid. After doing this, the program would check, does this centroid have one of each type of object? So that would be, in this case, a collectible orb, a key, an environment object, and a chess piece. So if it had one of each of these objects, then it would return true. This would happen for each of the centroids. If all of them returned true, then the environment would have been successfully created and all the objects would be clustered neatly amongst the environment. If one of them returned false, then it would repeat the clustering process again. So new centroids would be created and they'd be grouped to objects once again, and then the check would happen again. So this would keep repeating until everything was clustered nicely and the environment was looking good. This is also highly customizable, so the Perlin noise that generates this environment can be adjusted. So you can have an X and a Y offset, you can change the scale of the Perlin noise, you can change the cutoff point so more paths can be created or less paths can be created to make it look a bit more like Minecraft, for example. Overall, this was a very good project and it presented a lot of unique challenges that were very fun to overcome. Thank you for listening.